Hello and welcome to my channel, Abhishek's Learning Center. Today we will be looking into another physics topic, and that is pressure. So this is a topic of physics that is pressure, and we are going to understand this thing that is pressure in a very simple way. It is a very easy topic, and it's mostly related with the another physics topic, that is force. We know what is a force, and this pressure thing is also related to the topic force. So let's start. So what is pressure in physics? So pressure is a force that is applied to a unit area. Okay, so now by this we can write the equation that we write is P, which is pressure, equals to F, which is the force, upon A, which is the area. So we got pressure equals force upon area. So how much force is acting on unit area is pressure. And now we will look into some examples, but before that, I want to just show, I have just wrote the equation and force upon area, but by this, what do you understand? What do you understand? Okay, so this pressure is directly proportional to the force. What do I mean by this? That if the force increases, then the pressure increases. If the area per area, unit area is same, is constant. Now we take the opposite. Pressure is indirectly proportional to area. Okay, it's indirectly proportional to the area when the force is constant. It means that if the area increases, then the pressure decreases if the force is constant. Now we will take some examples to understand. Before that, we have to I have to tell you that what is the unit of pressure. So the unit of pressure is pascals. So Pascal is the unit of pressure. So now we know the relation between pressure, force, and area. We know what is pressure, and we know also the unit of pressure. So now we have understood, and we have I hope you have understood the concept of pressure. And now this needs to be looked from a different angle. And what is that? Examples are the best way to understand. And now I'm gonna show you the examples where you can relate this thing that you learned today, pressure, with that. Okay, so let's start with the examples. So now I will start with the famous example, that is you take a wall. You have two situations. You take walls and you have a nail, and you have a hammer. Okay, so you have two situations in here that you can very well notice, that we are having two walls, and where we are hitting a nail with the hammer. And you will see a difference in the situation, that here we are hitting on the flat surface, and here we are hitting on this the pointed surface. Okay, so now we have I've told you the example. So now let's relate this with our thing, that is pressure. So here, as you can see, this point is less area. So the area here that is on the wall is less, and the area here is more area. There is a difference. So one is with less area and one is more area. Now, as I told you, that the pressure is indirectly proportional to the force. Sorry, I told wrong. It is indirectly proportional to the area. Okay, Now, in both of the cases that we see here, the force is same applied by the hammer. But the area, one is less and one is more. So if the area becomes more, then the pressure becomes less. So here, as you can see, it will easily penetrate into the wall. But here, it will not penetrate. Because the forces are same, both of these conditions. But here the area touching the wall is less compared to this. So this would have a greater pressure on the nail and it would penetrate into the wall. But here it's the opposite, and I hope you understood it. Now let's take another example. So now if you touch the scalp of your scalp, okay, you will see that it's kind of like pointed on the top of the surface. You will notice that if you just feel it, if you just touch your head, it's not flat like this. It's of course not. So what does it relate? So when we ever put a heavy load on top of our head, both are of the same mass, same force is, so the drawings are different of the boxes, but they are same. They are of the same mass, they have the same weight. The force applied by the gravitational force is same. So the force applied by the two boxes is same. But the area here is less, the area here is more. So where we will find more pain? Here, right? Because the pressure would be more, because the area is less. And here the area is more, so the pressure will be less. And so you will feel less pain on your head. And so what, those people who carry luggages, they put a cloth around their head to make the head a flat surface, and by that they can easily carry those big luggages in their heads easily by a single person. And one more last example that I would give, the last example is that of a bag. So if you have noticed a school bag, of course you have noticed a school bag. Now you'll see the two strands of the school bag where you put your hands and put it on your back. You will see they are flat. They are not like line. They are not thin. They are flat. And why are they flat? To decrease your pressure. As they are flat, the surfaces are flat, the area is becoming more. As the surfaces are flat, the area is becoming more. And so these strands will apply less pressure on your neck, on your shoulder. Here, the area is very less. And so the pressure exerted would be very more. And so it would put a lot of pressure into your neck, into your shoulders, and it would eventually make it pain. So that's why we are having bags of flat surfaces. And so this pressure is related to everything that you see. It's related everywhere. To wherever forces you are seeing, you just relate this topic, pressure, by it. And then you will have fun, you will understand it. And that's it for today, guys. I hope you understood these 3 examples. There are many more, and I know you're all smart people and you can understand this in a minute. Okay, so I hope you have understood this topic, pressure, and we'll meet you in the next video. I want you to please subscribe my channel and also like this video and share this video to all your friends and families. And till then, goodbye. Stay tuned. Goodbye, everyone. Thank you for watching.